this video, we're going to be learning about ions, what they are, and how a specific example of ions, specifically those that are formed from nonmetals, actually form. So the dictionary definition of an ion is actually relatively simple, which is simply any atom that has charge associated with it. Now, if you remember, charge comes in two different varieties, positive and negative. Now, charge forms because of a difference in the number of protons and electrons, and normally, if we have an atom that does not have charge, the amount of protons and the amount of electrons are equal, meaning the amount of positive charge and the amount of negative charge balances itself out, and so we don't actually have more positive charge than negative charge. However, as we're going to see, ions are specifically what happens when we change the number of electrons in the valence shell, and by either increasing or decreasing the amount of electrons, that either results in negative charge or positive charge. Now, the way that ions form, specifically changes that occur in the valence shell to make an ion form, specifically occur when the electrons in the valence shell become full. So what we mean by full is that the outermost shell has the maximum number of electrons that is available. So if we're dealing with small elements like hydrogen and helium that only have a first shell, an ion forms when that first shell has two electrons. However, basically every other element has at least a second or third or even fourth electron shell, and the maximum capacity of the second and third shells is 8 total electrons. And what we're going to see, especially in future grades when you learn about how compounds form, is that 8 valence electrons is a fairly significant number that keeps coming back over and over again. And as a consequence of that, we have a special name for when the valence shell has a full set of 8, which is what we call an octet. So, for example, a set of 4 is a quartet, or a set of 5 is a quintet. Oct, as we will see, is the numerical prefix that means 8. So, that's a basic overview about what ions are. Now we're going to look at how ions form, specifically looking at fluorine, because it's a relatively easy example. So, fluorine is an ion, or fluorine forms an ion rather easily because its valence shell already has 7 valence electrons, as we can see in the Bohr-Rutherford diagram here. Now, we remember that the second shell has a maximum capacity of 8 electrons, and so if we wanted to make sure that fluorine's outer shell is full, it would need to gain 1 electron. So 1 electron would need to come from somewhere, which is pretty much always going to be another element. More on that later. And that 1 electron is going to occupy the single unoccupied spot in fluorine's valence shell. So the reason why this happens is, if we think about how a full shell can form, there are basically 2 options. Number 1, the element can add electrons, which is exactly what fluorine has here. Because it's only missing 1, adding 1 electron is relatively simple. However, as we will see in the next video in this series, losing electrons in order to get a full valence shell is also an option. So if we wanted to empty the outermost electron shell of fluorine, that would involve fluorine losing 7 electrons. However, that doesn't really make a whole lot of sense to do, because the easier thing to do in terms of number of electrons moving is just to add 1 like this. And fluorine behaves as a typical nonmetal does, because fluorine has more than not more than or equal to more than 4 valence electrons, meaning it has to add a smaller number of electrons to its valence shell rather than losing in order for it to become full. Now, what we can see here is that when we draw the Lewis structure of fluorine with its valence shell full, we now have an ion, and we can designate this using two additional details. The first thing that we can do is we can add square brackets around its structure like this, and this is a pretty easy way for us to identify that fluorine is in its ion form rather than the uncharged atom form. Now, we also remember that ions need to have charge, so the next thing that we need to do is identify what kind of charge fluorine has, and there are two ways to do this. Number one is we simply end up counting the number of protons and the number of electrons that an element has. Since the number of protons is in the nucleus and the nucleus is not affected by changes in the valence shell, fluorine will have 9 protons. Now, if we count the total number of electrons, 2, 4, 6, 8, 10, because of the one that we added, we can see that fluorine now has more electrons than protons, and if we designate each proton as being a charge of positive 1 and each electron being a charge of negative 1, positive 9 minus 10 is a charge of negative 1, which we can write as 1 minus in the corner like this. And this is a simple way that we can figure out the charge. If you would like an even more straightforward way, we can simply look at the number of electrons that fluorine is adding. So because we are adding 1 electron, that means that we are making fluorine more negative because each electron has a negative charge. Specifically, we are making fluorine more negative by negative 1. In other words, we are adding a charge of negative 1, and whenever we add a negative number, we are making the number more negative, which is exactly what we see here. So either way, if we look at the number of protons and number of electrons as a comparison, or we look at how adding or losing electrons changes the charge, we can end up with the conclusion that fluorine forms an ion with a negative 1 charge like this. Now, because all of the changes that are done to an atom when it forms an ion are done to the valence shell, it very often, instead of drawing the full atom out like this, we actually simply just draw the Lewis structure. So fluorine starts with 7 valence electrons, as we see here, and if we add 1 electron in order to give fluorine a full outer shell, we can draw the ion like this, along with the square brackets to show that its valence shell is full, and the charge in order to show whether fluorine has gained electrons or lost electrons in order to form an ion. Now, the only other term that we need to get out of the way is that now that we have identified that fluorine has a negative charge, we can give it a special name. So any nonmetal that forms an ion by gaining electrons is what we call an anion. So an ion is what it looks like. Technically, the emphasis is on the first syllable, anion, meaning negative ion. Now that we've learned how negatively charged ions form, in the next video, we're going to be looking at the counterpart to negative ions, which are how metal atoms form ions by losing electrons, rather than how nonmetals form ions by gaining electrons. So join us in the next video when we take a look at the counterpart to anions.